Will, it's finally happening. My day job and the FossPod.
Video games. Oh, sorry. Shit.
Wait, wrong video game podcast.
My bad. Yeah, we're doing a video game episode. It's funny, when we started doing this podcast, I remember having the conversation that there weren't that many open source projects in games. And then I feel like we went down we made the list of open source projects in games, and like there's obvious stuff like, Tux Racer and Doom, the Doom engine, and Quake engine, all the id engines up until the point that Carmack left the company. But there's also kind of a lot of stuff happening. Like Preservation has traditionally been an open source bastion.
Yes, Retro, I would say, is maybe the hottest place that open source video game stuff is happening, with MAME and a bunch of other stuff of that nature, emulators.
I mean, there's a lot of interesting middleware and back-end stuff that is decidedly uninteresting for like normal human beings, but shows up in every game that everybody ships, right? Like there's audio engines and stuff like that people can use if they're making their own games. But yeah, the emulation and preservation side of this is really a big deal. And I think the most interesting part of the emulation preservation, with respect to MAME, is what's happening with FPGA emulation stuff, at least to me.
I have a passion for packing a lot into a little.
Okay.
What I mean by that is the ratio of number of old video games that can be recreated by a given device. Like the higher it is, the better. And
the smaller the device, the better?
Yes. And in that respect, like there is nothing on the market that compares to the MiSTer project, which is what we're talking about today, because probably the games that it can play number in the tens of thousands, if I had to guess. And it's about the size of like 2 Raspberry Pis stacked together.
Yeah, it's an incredibly dense little thing. And also, it's not just for game emulation. It also emulates a bunch of old computers up to and including a 486. So
yes, it's a remarkable device, and I feel pretty excited about the caliber of the guests that we've scored this week to talk about it. So here we go.
Welcome to the FossPod. I'm Will.
I'm Brad.
This week's episode, as always, is brought to you by Google Open Source. They bring all of the value of open source to Google and all of the resources of Google to open source. You can find out more about Google Open Source at opensource.google. Brad, I'm really, really stoked this week because on the FossPod, we're talking with José Tejada Gómez, who is the creator of open source cores for the MiSTer project and the MIST project before that, and other projects as well, which we'll talk about during the interview. But you may know him not as José Tejada Gómez, but as
Jotego.
Jotego.
Yes, Jotego is like one of the heroes of the MiSTer project. Like, there are a lot of developers making different cores for the MiSTer project, which a core is analogous to a system, like a video game console or an old computer, essentially, or an arcade board, which is what Jotego focuses on primarily. I guess for people who don't know, I mean, anybody who listens to me anywhere else has probably gotten sick of hearing about the MiSTer at this point. It's been one of my passions for the last 2-3 years, but just real quick setup, we should probably define what an FPGA is first.
Yeah, so it's a field programmable gate array. It's basically a special kind of processor that, from the outside looks like a normal, like any other chip on a little board. But the difference is that you can reprogram it to mimic the hardware circuits and even like the chips and the processors that are on these old devices. And you can change it from moment to moment. So you basically run a script, and the script loads this thing called a core, like you said, onto the chip. And it physically restructures the way the electrons move through the chip based on the software that you're loading onto it.
Yes. Basically, electrically reconfigures itself to more or less be those old chips.
Yeah, and the benefit of doing this versus, say, using MAME or a SNES emulator or something like that on, say, a Raspberry Pi or a normal Windows PC is that you get the things that are difficult to emulate in software because they're either computationally really expensive or in some cases just you can't emulate them, happen automatically. So the canonical example I used during this interview is the Sega Genesis shipped with 3 different sound chips, right, over the course of its life. And depending on which Genesis you got, the music you heard was slightly different, like the tone and timbre of the notes that were played. The notes were the same, but the way they sounded was different. And when you load up a normal Genesis emulator, I think you can switch between those. It's never exactly sounds right. When you load up a MiSTer, the Genesis core on the MiSTer, you choose which of the chips you had, which in my case, like involved loading up a game, switching until I found the one that was like, oh, this is the one. Yes. And it was really, really exciting. And so there's two benefits. One is that you can emulate stuff directly. You emulate the hardware rather than the emulating the software. The other is that the latency is really good when you're playing on modern HDMI displays, because there's no analog to digital conversion like you would if you're playing on say an old SNES hooked up to the TV.
Yeah. Yeah, I had a field day with this interview, just having been so deep into this project. I kind of just self-indulgently asked him everything I wanted to know, but like that was one of the fun things to dig into with him, is that there is, for better or worse, a little bit of factionalism between, like, say, the MiSTer community and people that like software emulators about which one is better, which one's more accurate. Is the MiSTer even emulation, or is it replication? You know what I mean? Like, it's a little bit tribal in that respect, but he gave some pretty sober analysis, I think, of that situation of like, yeah, there are some ways that software emulation is better, but it's also limited in some ways. And here's where the MiSTer is better there, but the MiSTer has its own unique limitations and issues. Like it was fascinating to get his take on like, is the MiSTer more accurate? Like, what are the ins and outs of that? Like he gave a ton of fascinating detail.
Yeah. So at its core, the MiSTer is a D10 Nano with some of their boards stuck on it that handle input and output and give you more memory and stuff like that. It's a pretty simple build to put together. You load an open source project that's based on Linux onto the ARM core that lives on that board, and then you load the game cores from the Linux build. It started mainly as console and like old PC replication, but the thing that Jotego does is arcade boards, and he's focused on that from the very beginning. And for folks who don't know, in the early days of arcade games, boards were kind of all hand built for each game and were distinct. So like a Pong board and a Miss Pac-Man board look wildly different from each other. But as the technology progressed, the companies making the games would be, one company, instead of it being one or two people making one game and then making a completely different game a year or two later, the same companies would be making the same games, and they'd often ship new software on the same hardware that they'd shipped previous games on, which presents an interesting opportunity for people like Jose who are trying to replicate boards, in that they can do work on one board and suddenly unlock, 5, 10, yes, sometimes more games.
Two dozen games, it's like, yeah, Capcom had its various platforms. Midway had its own unique hardware. Every company that was out there making arcade games. And you would even get situations with the bespoke boards where individual chips were shared between different boards, right? It's like, this Konami board that was used for The Simpsons and Ninja Turtles has the same like sprite hardware as X, Y, and Z. You know what I mean? So like, and the thing we should mention, and one of the most unique things about this interview, is that Jose is the first electrical engineer, the first circuit designer that we have had on the show, as far as I know.
At least that we're aware of, yeah.
Yes. Maybe somebody's got a moonlighting hobby, but yeah, by day he is an analog circuit designer, and by night he has essentially become kind of a digital circuit designer, and he gets to talk about those distinctions.
How workflow, the whole thing. It's a really fascinating conversation.
Yes. I think that's most of the topics we need to cover. One thing that, just in case it's not clear, one potential point of confusion, he works for a company called Analog Devices.
ANALOG Devices.
Yes. We also reference a completely different company called Analog with a UE at the end after the G.
Yeah. Analog Devices makes chips for companies around the world. They sell bazillions of chips to people.
Like they're pretty old school, right? I think they've
been around for a very long time. They decades. Do DSPs and audio DACs and stuff like that. Like you have definitely used devices that have Analog Devices chips in them.
So Analog with the UE, the newer company, actually predates the MiSTer project in that they have also been making FPGA based video game console replication hardware for quite a few years now, but there is a little bit of friction between them and the MiSTer community because Analog does not open source any of its stuff, and with their newest handheld, the Analog Pocket, they have started soliciting MiSTer core developers to contribute, and there's a little bit of some strife there, which we touch on a little bit just to set that up a little bit between here's a company profiting from some open source work while not open sourcing stuff themselves. And so we touch on that a little bit, and he has some really interesting thoughts there too.
Yeah. But at the end of the day, the MiSTer project and most of the emulation stuff that happens in open source and closed source world is about game preservation, because the thing that I don't think I understood until fairly recently is that there is a shelf life on all this hardware that was built, especially in the late 70s and early 80s. And going forward, the boards don't last forever. The data in the ROMs doesn't last forever.
Yeah, there are even weird edge cases, like some of the Capcom CPS hardware had old like encryption that is time limited in some fashion that I don't fully understand, but like that even has an expiration date.
Well, and I believe there were boards that had DRM on the boards that required a live battery, and the batteries were soldered into like, so you have to basically hot jump the battery when your 20-year cell dies, or the board is dead. Well, like once that battery dies, the board is unusable. So
yeah, so to me, there's really an element of doing a public service in this work, in that yeah, like a lot of this hardware will not be playable after some number of decades, and so with the kind of work that Jose is doing, like those games will live forever.
So without further ado, let's jump into the interview with Jose and talk about how you make a FPGA core for the MiSTer.
So you're best known for the work you've done with arcade boards rather than home consoles and old home computers. What has drawn you to working on arcade hardware specifically so much?
Well, the only work I did on the consoles was the sound of the Sega Genesis and the Neo Geo, if you call the Neo Geo a console. But that was more of a collaboration, and I found that for arcade systems there were good schematics, and no one was looking at them at the time. I mean, there was some work done in very old games, but not in the games I was interested in. Whereas for the consoles, there were a lot of people interested, because they draw more attention. So I thought that part of the space was already covered.
I guess there were schematics so that arcade runners could maintain the machines, right?
Yes. They all have these confidentiality statements in Japanese. I don't know whether that applies anymore or not. I don't know what the laws are about that. Because I think in Spain, if you want to do something confidential, you have to pay for a protection to register it in an office, or I don't know, maybe if it is a company, you don't have to. Yeah. I'm curious, because I mean, like all the documents are in the internet anyway. It's not like we are stealing it from some office, but it's all up there. But I don't know what the legal status of those, all documents is.
We are not lawyers, so I'm not going to speculate on that.
Yeah. I know you've made some changes recently where you've got help now on the engineering side, but before you put those changes into place, when you were doing all the work yourself, could you just briefly walk us through, like, what's your process when you start a new core? Like, where do you begin, and how do you unpack that?
What got me interested in this was the availability of schematics, because the schematic is like the whole truth of the design. It tells you where everything is, how everything is hooked up, so you don't have to make any guesses. Because I wrote emulators in the past, like when MAME was starting, I was also writing emulators at that time, and it was basically going through the DOM, disassembling it and trying to guess what the software was trying to do. And you build everything from assumptions. And the beauty of the schematics, especially in the early games, was that there are no assumptions. You have all the information there. So there was the theoretical possibility of just recreating it exactly. And that was really fascinating. So I always start by getting the schematics and understanding them. Of course, in some games, the schematics may have like custom chips that obfuscate some of the information. And sometimes sometimes they do very simple things, so they are not really a problem. Other times, they can be tricky. Then we have opened some of them, we have extracted the circuits from some of them. They are a problem because like the alternative to looking into the schematics and cracking the chips open is just to look at what the emulator does. But if you just do that, then you are not bringing anything new. Right? You're not bringing new information. You are bringing a new implementation where everything works in parallel, and you are already. Just because of that, the experience is better, because there is no, emulation of one thing after the other, and the like threads in a multi-thread CPU. It's not like that. Everything is in parallel. Just by doing that, the experience improves a lot. But in order to actually add something to the community, you have to do the research, and that's why I hired this person to extract schematics, which is it's very time consuming, because for a lot of boards, there were no schematics, but we had the board. So we could still extract the schematic and don't give up on that.
What's the process? I mean, do you just take a photograph of the board and then start following traces to build the schematics?
Yes, well, we do it with the board directly measuring with a multimeter. We haven't made any tool to do it. I have seen that there are some tools. Probably if you ask people around, they may think that I make a lot of money with the Patreon, but the reality is that, once you take the fees, the taxes, and so on, you don't have so much to pay people. And so I cannot really afford people who are very experienced and who know a lot. So what I have done is I have looked for people who can be useful in a small task and who can learn that very quickly and who are happy to work for what I can pay with the Patreon funds. And yeah, especially with this person doing schematics for a year, it has worked well. Like, probably if I had senior software engineer, who knows how to, dissect a problem and create an awesome software, we could be doing it faster, but I don't think I can afford that person. So
what's the process of decapping some of the chips on these boards where you don't have schematics? What is that like? Is that dangerous? I mean, there's only so many of these boards left in the world. Like, are you running the risk of destroying it and making it useless if you're not very precise?
Yes. When we do that, you have to throw the things away pretty much. I mean, you can keep them but they are basically broken because you have to desolder them, and some of these chips, they may have 300 pins, so you are pretty much bound to break the chip when you desolder that, unless you are very good. But even if you don't break it, now you actually have to open a hole in it, and you can do it with chemicals, and if you do that, you are in risk of dying in the process. So you have to do it in the open, and you have to be careful. So I haven't tried that myself. Fortech is doing that in France. And, I think he goes to a party or something when he does it, and, he's very careful with the fumes. The other option is with some packages, they are ceramic, so they can actually crack. And that's easier. Then you just protect your eyes and you can just try to break it like a chair.
So your process for something like this is first you take the board schematics, and then you identify the chips that you know and have models for, right? So things that you've opened in the past, and this is this DSP, this is this memory controller, whatever, and you place them on the FPGA, and then you have all these custom chips that you then have to figure out what they do and basically model these one-off chips that somebody in Japan designed 40 years ago. And
yes, yeah, it's pretty much like that. Even if I have all the circuit of a chip, I very rarely make a one-to-one translation because the underground technology is different. That chip, that logic was designed with some primitives, and a modern chip has different primitives. So the right thing to do is actually to translate it in a nice way for new technology. So you keep the same, the same output for the same input. You keep the same function, but you do it in a the way things are done nowadays, which is, following some design rules, some, good practice and so on. So there is always a redesign. For instance, just to be more specific, the CPS2 has a frame buffer for sprites, which means that the CPU writes to a table and say, these are the sprites that I want to see the next frame. Well, 2 frames from now, actually. The CPU writes that. And then the hardware looks at that table and draws all those sprites in a memory. And they are there for the following frame to be dumped. And it does that for the sprites, but not for the backgrounds. The backgrounds don't have that delay. There is no frame buffer for backgrounds or for the text layer. All that goes 1 frame before the sprites. So if I do it the way the CPS2 does it, then I need this big memory for the frame buffer. And I need a lot of bandwidth to communicate with the SDRAM. And the thing is that I have a high-speed clock. I have a technology that can support a high-speed clock much faster than the CPS2. I think the CPS2 was running, it was 16 megahertz, the graphic clock, and I have one running at 96. So I can do things much faster than they can. So what I do is, instead of having the table where the CPU writes and then the buffer for the drawing, I have a buffer for the table. So I have that frame buffer. It's not for graphics, but for the table where the data is for the sprites. And then I just use like a regular line buffer to draw sprites on the fly within the same frame. And by doing that, you save a lot of memory and you save bandwidth. You also save power. It's a different architecture, but you cannot distinguish it by looking at the inputs and the outputs. The way you distinguish it is that because of that, it can work in smaller FPGAs. I don't need to have the MiSTer that has a SDRAM and a DDR, and they use the two memories to do the frame buffer. I can do it in an FPGA that only has one memory.
This is kind of a random question, but how often are you having random arcade boards just show up in your mailbox these days? Are people inundating you with hardware, like begging you to like, please do a core out of this one, I'll sacrifice my board for it?
I used to get more, but nowadays I don't encourage people so much to send me boards because I have had some problems with with customs. They don't work very well. Like they just send you a random notes and they ask for any amount of money, and you cannot really talk with them. And if you don't see the note in time, one time they even return the boards. And someone is selling you the boards because it's a big deal for them to get the boards over, send them. It's something very valuable. It's like this treasure. And to have them return back to them like 3 months later, yeah, that's a very bad experience. So I've been turning off some people who wanted to send boards from outside the European Union because of that. Within EU, it's okay because there are no borders, there are no customs. But yeah, the problem with the customs is, I don't like these customs guys. No.
It turns out they're not as interested in arcade game preservation as we are probably.
Exactly. Yeah. They should open them and see, oh, this is a Miss Pac-Man. No, this has to go through. Yeah. Green. No, instead of calling me.
I'm curious about your pipeline for the actual FPGA work. Are you able to use mostly open source tools for that? Or I know that you've expressed a preference for that in the past.
Yes, I try to only use open source tools, and it's a bit hard. It actually forces the way I do things. Like there are these two different languages. There is Verilog and System Verilog. System Verilog is more modern. You can do things a little bit easier. But open source tools don't support System Verilog well. So I just don't use it. Because I think in the open source business, we shouldn't like sometimes people come to me and say, look, I have this, this key, so you can use this, this privacy, this private tool, from Cadence or Synopsys or something. I say, yeah, I don't want that. I cannot take that in. I need to make the force tools work. So I use Ubuntu Mate is my operating system, and nowadays I tend to use only the Go language as my when I need to write like a little piece of software. Then a lot of bash scripting. Then Verilator and Icarus Verilog are the two tools for simulation that I use the most. Then there is one tool called GTK Wave that is a waveform a tool that shows you the waveforms from simulation. And then, I use Sublime Text for editing. I think that's not open source, but it works on Ubuntu.
Still very popular. How much maintenance work is there for previously released cores? I mean, does everything have maintenance, or do any of the cores ever just get to the point where, okay, this is 100% done, I'll never have to touch this again?
Well, the core itself, I have a few cores. Well, I think I have many cores that I think, as far as I know, I think they're perfect. But, you can have a regression problem. When I update the framework and I change something in the framework and I recompile, I may introduce a problem. And I may be forced to modify something because maybe they have this new option in MiSTer and people want me to add support to that. So then I have to go back and recompile. And then you have to retest again. And I think the number of games, including regional variations and so on, that I support at the moment is close to 900 games, I think. So it's a lot. So it's something that really you cannot maintain. If you are a one-person show, you cannot maintain all that. So
I've seen you talk a lot about your framework, JT framework, that you've developed as kind of a common development base. I'm not a developer myself. I'm kind of just a layperson. Could you just give a little detail about what that framework entails? Like, what are the pieces of it, and what does that give to other developers who want to use it to make cores?
yes. So when I started developing for the MiSTer, which I took what Sorge was doing, and I was a bit surprised that the center of the design was not the core, but it was the MiSTer. So I'm thinking, why the MiSTer is here at running the show? It should be the core. I talked a little bit with Sorg about changing that, but he had his way of doing things, and it was working for him. The point is that he has one way of doing things that it's probably easier if you don't have a lot of background in these things. It's probably easier because you just copy the files and modify here and there. Whereas in my framework, if you look at the top level of the design, you have one block which is the game itself, the core, and another which is your connection to the board. And that board could be a MiSTer, could be a MIST, a Pocket, or whatever. So those are the two hardware elements, the two blocks that you have at the top. And then the game one will develop differently for each core, but in general, they are very similar in terms of of the diagram of the pieces that they are made of. And then they have a common interface to connect to the other side. So when you are working within this framework, you pretty much can forget about the other stuff. So that's one thing, that you only have to comply with an interface that is like very minimalistic. It's pretty much what the board would have, like video, sounds, the joystick, the coins. So that's one thing, that the priority is given to the game. And the other thing is that I provide a lot of basic functions for the cores. Like there are like memory modules, an SDRAM controller, audio modules. Like there is a lot of basic functionality that is already there and that the games can just use. I was always surprised that wasn't part of the MiSTer framework, that the MiSTer framework was just trying to do something with the core output signals, but it wasn't doing things to make core development easier.
So this framework, I assume building this framework from the beginning was one of the things that let you be so prolific. Like you've released a stunning number of cores over the time I've been following the MiSTer project.
Yes, it's like I think I have two secrets. One was the framework, and the other one was simulation. That most people, even nowadays, are not running simulations. And if you look at modern chip design, if you go to Intel, they have more people running simulations than designing the chip. So that's the level of importance that simulations have in the industry. So because
we're definitely not chip designers over here. So when you run the simulations, what are you doing and what are you getting from that?
Yes. So you are writing your code, right? You are designing your core there, and you want to test it in the MiSTer. So it will take you, in my machine, it usually takes over 15 minutes to compile a core for MiSTer. So if you have to run these compilations for each change that you do and each mistake that you correct, you'll pretty much be all day waiting for the computer to finish. So that's not practical. And then when you compile, you only see the thing whether it works or not. And then if you want to look at some internal electrical signal in the FPGA to see whether it's moving the way it should move, you need to recompile again and tell the compiler that I want you to keep this signal and send this over USB to me, to the computer, so I can see it. So then another 15 minutes, and then maybe you discover that is not the signal that you wanted to look at, that you wanted to look at a different one. Another 15 minutes, and so on. So you spend all day pretty much compiling instead of designing. And a lot of people, even nowadays, a lot of developers pretty much do that, spend their day compiling. And that's very slow. If you set up a simulation, the simulation is kind of a hardware emulation done in the computer. It's very slow compared to it's not an emulation like main that is real time. These things are very slow because they they simulate, every electrical signal. For instance, it usually takes to simulate 2 seconds of the hardware. It could take maybe 12 minutes or let's say 6 to 12 minutes. So it's very slow. But when you simulate that, you can keep all the signals in the screen. You can look at them moving. So, and if you do a specific test benches, you can just isolate one module, test one module at a time. It's like in software, when you do unit testing, you don't test the whole software suite, but you only test, a module here, then a module there. So it's similar to that, and you don't need to build the whole FPGA thing to test it.
So instead of taking 15 minutes to test one thing, you can take 12 minutes and see the entire state of the part of the machine that you care about.
Yeah, for instance, yes.
It seemed like the things really took off for MiSTer when Intel started subsidizing the D10 Nano boards. Do you think that's correct? I mean,
this is correct, yeah. I know that, yes, the FPGA alone from MiSTer is more expensive than the whole board. So, yeah, that's been sold at losing money. MiSTer FPGA is really a very large device, and we actually don't need so much. Like, there are a few cores that use that, like the PC, the 486 core, the PSX core uses a lot too. I think maybe the SNES core because of all the mappers or something, but you could design it in a different way, so it wouldn't need that space. It's also a matter of design. And I've been able to get all the games in FPGAs that were much smaller, not without effort. I mean, I get them inside because I make design decisions so they will fit. So because you can do things in many different ways, and if you want to save area, you have to design for area. So you could have like a lot of the MiSTer functionality in a device that is maybe 4 times cheaper. And the analog pocket is indeed much cheaper than a MiSTer FPGA, and it's also a fancy device with a battery, a screen, and so on.
It has to feel bad to You've often talked about doing this kind of emulation for preservation. So the idea that you have to destroy this thing to preserve it is yes. It's got to be a weird feeling. Yes.
So I always, when we do that, it has to be with a broken board. So you cannot save the whole system, but at least you can use some of the devices to preserve the knowledge. And once you have it preserved, you can replicate it. Like, we normally don't do it, we just replicate it in the FPGA, but in some cases we have actually replicated, from the work we've done for the FPGA, we can replicate it chips and put, them in old boards, and they work, and they are replacement for the old systems too.
So you touched on this a little bit when you talked about FPGAs being able to execute in parallel as opposed to kind of linearly, like software emulation. But there's a big debate that I'm sure you're aware of in the community. Is FPGA recreation emulation? Is it perfect, authentic replication? Where do you fall in that debate? Do you feel like your work is perfectly identically recreating the hardware, or is it still as subject to like bugs and workarounds and inaccuracies as software emulation?
I think you can do emulation too, in the sense that, for instance, like in my 1943 core, I don't use the MCU that the original system had, because at the time it was like my second core or third core or something, so I didn't have that piece of IP at the moment. I have it now. I didn't have it at the moment, and I saw what it was meant to do. It was actually just meant to look in a lookup table and return a value to the CPU. So I emulated that with some logic. So it's hardware emulation because I'm emulated an MCU with some circuits, with a few gates. So that's an emulator. But in other cases, it's not an emulation. It's actually just the same circuit. Or you could say that it's a different implementation. Maybe implemented with different primitives, but that's like if you replace a chip in the original board that is from the 74LS series, and you replace it with a 74 HC series, which can be compatible in some cases. You just replace them and it works, but it's not the same logic. I mean, it's not the same device, it's not the same transistors. So, I mean, you wouldn't call that emulation. It's just a different implementation with slightly different technology. So most of the time, it's just that. It's just a different implementation. And sometimes, like in that core, it has a part of it is simulation. And I could replace it. Now I have the technology to replace it for the real thing. And I haven't done it because I know that it's something that no one will notice because you know that it doesn't have an effect. You know that some things have an effect that have been noticed, and this one doesn't. I guess eventually I will replace it just for completion. But yeah, it's low in the priority. Like, I think people wouldn't understand if I spent 3 days doing that. But
I like to think of that as it's like you have two physical objects in the real world, and if they're set up and the lights are the right way, then you can cast the same shadow with two objects that look wildly different. But the impact of them on the ground is the same, even though they're created in different ways, right?
exactly. I think that the point of comparison should be the output signals. So for the same input signals, do you get the same output signals, at the same time and so on? So that's what I try to get. Like, if you could emulate like a circuit using a CPU running fast enough that, generate all the signals at the right time, it is still the same principle. You wouldn't be able to tell the difference. If you could have many of these CPUs running in parallel, it would be the same. It's just that, in the software world, you don't have so many CPUs and you don't have the control. But that could be another approach. Sometimes I look at that. When I have a new block, I do some calculations of whether it's going to be worth doing it purely hardware or having some logic, some software logic inside running at very high speed. So all the signals are created at the right time. And you reproduce, same inputs, same outputs, but instead of using purely hardware, you use hardware plus a firmware. But so far, the calculations have only been that I couldn't get enough clock speed to do that, because you need to run things very, very fast to be able to do that in software.
I wanted to ask, we'll get into more later some of the changes you've made on the kind of business side and the way that you support your work and the people you work with, but do you still have fun doing it? Does it ever feel like a second job, or do you still get excited to dig into stuff and put these things together?
I think having people hired takes a little bit of the fun away, especially because of the government, because suddenly you are responsible for a lot of things, for paying taxes, social security, things that you normally don't care about because other people were paying those for you, so you didn't have to know about those things. So that's a bit of a pain. You also have to listen to the problems of these people. Like, I cannot come today because I have to go to the doctor, whatever. So that part, it's not fun. Like, I wouldn't do that for. But I mean, the problem I have is that I have a lot of subscribers, so it wouldn't be fair if I just kept all the money to myself. So I think that the money is there because people want to see output. So the only way I can get more output is to try to get people working. So I think that's the responsible thing to do, to take that money and place it in a way that produces output. That's not so much fun. Like the fun thing to do is that you only work on the part of the project that is interesting to you. But I think that's what happens with all open source projects. Like, you get a lot of people that start an open source project because they are interested in something. And the challenge comes when your curiosity has been satisfied. So now you know how these things work. So now you've proved that you can do it. So you don't need this anymore. You've made your point. But who is going to maintain all this pile of software that you built on? And now there is people who rely on that. And when the maintenance point comes, I think that is when you need the funding and the economic side to it, because pretty much no one wants to do the maintenance for free because it's not fun.
It's work.
It's work. Yeah, exactly. It's 100% work.
So you touched on this a little bit, that you've got your framework. You mentioned Sorgalig obviously has his own way of doing things, and it's a very popular project in general. The MiSTer has a massive community, a lot of fans, and a lot of contributors. Was there a sort of political aspect to navigating that community where there are different strong opinions about how to do things, and some people align with one and some people align with the other, and then people are like, okay, what's the official way to do stuff here? Has that been difficult to navigate?
I used to be strongly criticized because of not using the official framework and also because of the early access policy to the course. But I think that I've been proven right with time because my framework has been useful, at least for me. I know other developers have tried using it, and there have been other cores released using my framework, but they haven't used it like 100%. Like if you look inside MiSTer official cores, there are pieces of my framework, that have been, copied over there. And then there are people who have, copied like, let's say 90% of it, but not all of it because maybe they were using Windows and my framework depends on Linux, things like that. So that was one thing. The other thing, there was a lot of tension about people who wanted to copy my course to the official repository. And that would have been a problem because then that would confuse users because who is maintaining the official core or the core in the official MiSTer repo then? I mean, are they going to be copying my files each time I make a change? So it didn't make sense. I think that if you have a developer who is maintaining the files, then you don't need to copy them. Just let him maintain the files. He's already doing the work. Then the other part was the early access that, the fact that I release course for a while, usually for a month, with this mild DRM system that blocks the inputs if you don't have a file. A lot of people didn't like that, but that's the problem with open source. You need to give a little bit extra to the people who are supporting the project. But at the same time, the people who support the project want you to actually give it for free too. So the only balance there is like early access. Because then if you have a game that that is a catcher, some people will join and then they will see other things of the project, and most people like the work that we do in general, and then they end up staying for a while, and that's really, really helpful.
Just to clarify for people who don't know, so essentially your model is that while the cores are still in development, your patrons get access to them, but then once they're sort of quote unquote done, then they go wide release, free, and the code all opens up at that point as well, right?
Yes. A lot of the time, the code is open from day one. It's just that people don't look for it. And I guess that at the beginning, it was more interesting for other developers to look for the code. Now they all assume that it's going to be there in a few weeks. And normally it's there from day one. It's just that I don't say the place. But if you look in my GitHub, you would find it, actually.
I want to talk a little bit about the restructuring you've made with your Patreon and your general business model recently. You announced a couple months ago that you're sort of stepping away a little bit. I think you basically said you've kind of detached yourself financially and legally, I believe is how you put it, from jotego as a business. Was that driven purely by like your workload and it was just too much, getting to be too much to handle? Were there any considerations with your employer there that drove that?
Yeah, so it not so much with my workload. But it was because of my employer, because of the tax agency, and also because of, let's say, my workload with, let's say, my home workload. So if you go one by one, like, for my employer, I should not work for any other company, including my company. So, and the thing is that even if I was taking all the money from Patreon myself, I wouldn't be making as much as I do with my employer. I mean, that doesn't mean that I couldn't, make the change. But again, I can do so many things in the FPGA scene because I work where I work. And I work, in a company that is, at the front end of all the electronic development nowadays. Like it's the third largest company doing ICs in the world. So it's really like a heaven for someone who likes electronics to be there. So I wouldn't like giving that up. So I needed to detach myself from that. It's okay if I do open source development, but I shouldn't be involved financially with that. Okay, so then from a tax point of view, if I am the owner of the money from Patreon and I am on a payroll, it's you pretty much work for the government then because they take all your money, so you make nothing. It's incredible. And then at home, I had to do my wife was working full time. I was having the Patreon, so we weren't able to get things done at home. So it was very stressing because even if we tried to get help to get things done at home, it was still not possible. So the right move has been and it will start being effective next month actually, to get my wife working on Patreon, on the business side of Patreon, like dealing with all the relationships with with social security, employees, project management. That I've made a list of a ton of things that are not about core development that she can do, and then she will also have more time to take care of the house than I am. So then she pays taxes for that money. I don't pay taxes for that, so less money goes to the tax office. And I get more time to the course because I need to recover some time to that, because I've been losing time to that because of all these other things, because you have to present your tax papers every 3 months, and then you have to manage the employees and so on. So I need someone to push that because there is still a ton of work that I am the only one who knows how to do it. So I need time to do that. So
it's kind of the classic problem of you can't focus on the thing that you're good at or the thing that only you can do because you're doing all the administrative stuff to keep it going, right?
Yeah.
Going back to the CPS3 question, how do you decide where to prioritize your time in the time of the jotego team?
I try to hear to everyone, and I hear to what directors want, but you would be surprised that a lot of time directors are just happy to see things moving and that we don't stop. And they have some ideas, but they are not very pushy. So I try to get a sense of what the community wants and is waiting for. So a lot of that comes from that, from people comments everywhere, or I run polls to see what people's interests are. And also sometimes I try to get a little bit of low-hanging fruit, so I can produce some output when I haven't had much time, because sometimes you have background activities that take you a lot of time, but people, wouldn't appreciate them. So you need to produce some output. So then I would look for a core that can be quickly done. And very rarely, but sometimes I look for a core that I want to do myself, because it's a game that I want to have. Like, for instance, one of those cases would be Vigilante, that I wanted to play that game. Not many people had asked for it, but it was not hard to do, and I wanted to play it, so I did that one for me.
Is it safe to assume that CPS3 is by far the most requested core at this point?
They request it a lot. I'm kind of surprised because it doesn't have so many games. It only has like 2 titles. And it's a very, very complex system. Like, if we do it just porting from main, it's complex, but it would still take like a lot of work, but I don't know, maybe a month or something to do. But if we do it like the right way, trying to add something, cracking the chips open and so on, it's going to be a big effort, because the board is full of big custom chips from Capcom that you know nothing about. So even if we make the schematics, it's not going to tell us much unless we start cracking these chips open.
Okay, it's time for my one self-indulgent question. Of course, everybody has their pet core they want to hear news about, so here I go. Mortal Kombat, you have said, I saw a tweet from earlier this year, I know it's not like priority 1, but you had it listed in a kind of a long-term roadmap of things you'd like to get to. The only thing I'm curious about is, are you just targeting that first game? Because there's the whole Midway continuum of like T-Unit for Mortal Kombat 2 and NBA Jam. Like, I think MK3 was on Wolf Unit. When you say Mortal Kombat, yes, do you think eventually you're looking to do the whole Midway ecosystem?
It's the whole family, yes.
Okay, great. Thank you.
And I have good news and bad news about that. The good news is that it's still in the plan, it's still in the roadmap. I'm very interested in that myself. The bad news is that, this person I hired to work on CPU development, I don't think he'll be able to do those things. Like, I've been working with him now for over a month and a half. And I think it will be helpful with a lot of things, but I don't think he will be up to the challenge to design these CPUs. So that, leaves me again alone as the only person who can do it, and I have the other pile of work, so that, I have to see how I balance that. Or I don't know, if we get a lot of Pocket users and we are able to hire a person, who will be more experienced, then. Because the problem with these projects that have different CPUs is that the CPU development is not easy. It takes a long time. And when you see arcade cores, popping up here and there from other developers, it's usually because they have been able to put together pieces that were already there, like the 68,000 CPU or the C80 or the FM chips that I developed for other arcades, or the Neo Geo or something. So the pieces are there, and then it's only a matter of connect them. And that's not easy. I mean, I'm not saying that's not easy. But if instead of doing that, you have to make one of those CPUs, like now we are talking again of a very long development that requires more experience. And that's the problem with the Mortal Kombat. The Mortal Kombat has two such chips, because the video chip is like that, the sound chip is like that too. The sound chip comes from Analog Devices, which is the company I work for. I was talking with the general manager of DSPs to see if we could get access to that chip. And he was actually positive about it. And we talked a little bit about that, because we could frame that in an educational way for universities too. We could promote the D10 Nano with, some tutorials from Analog Devices using this DSP as an example. So the whole thing could work out for Analog Devices. It could work out for the retro community, for students. It was a good plan. The problem was that we found that chip, that Analog Devices had licensed that chip to a producer, to a second company, and that they were still selling it. So then there was a conflict of interest there, because now Analog Devices cannot publish information about that chip that they have licensed to a third party. So that cut off that part of the segment. That was a big pity, because we would have had the real thing, the original one supported by the original creator. So that was a big disappointment. It also puts me a little bit, in an odd situation, because I'm not sure whether I can make a public open source core myself for that chip. I guess I would need to ask for permission about that. Even if it is not the original code, is it okay that an Analog Devices employee releases such thing or not? We were discussing that with Mr. Athons, who sells, he sells the Athons and so on. So one option was actually to make a small board to connect to the MiSTer that has that chip, to get around this problem. Because, it is a chip that it is still produced. It has an analog output, so it actually makes sense, because you will be able to connect your analog output from there and get the original, the original feeling with the original sound color. So that could be one way around. Another way around would be if someone who is not me makes that part, makes that DSP, because they wouldn't have the conflict of interest.
That's always the give and take of open source projects, right? Patience is required, ingenuity is required, because there's not massive corporate funding there. You have to, just be patient and let these things work themselves out, right? I've kind of thought of you as kind of being at the forefront of using crowdfunding platforms like Patreon to support open source work. That's a topic that we're just generally interested in on the show, and I think you're one of the more successful enterprises to try that so far. But even then, like you said, people look at your Patreon and think, oh, he's making so much money, but then there's platform fees, taxes, X, Y, and Z that cut into that. Do you think there's just a kind of a low ceiling for potential support on platforms like Patreon for open source work, or do you think that support could be much higher, or is it just generally going to be kind of a boutique, smaller thing in general?
I think, there are people who are making an awful lot of money in Patreon just, reading the tarot, these cards. So you can make money with pretty much anything in there. I think what makes it hard to make it with open source software or hardware is that there is a whole different aspect to Patreon that is not what you do. That is not let's say your product, your software or your hardware, which is the interaction. Like, you get a lot of messages from people. You need to keep people entertained in the end, and you need to know what they are looking for. So you cannot be purely technical, because if you are only technical, you are going to lose your audience, because maybe your audience is not so much interested in how you do this or that. Like, I think my audience are people who have a love for these games, for these systems, that there is almost like a feeling of these things like being sacred, like this feeling of awe, which I also share that. That's why I understand it well. And I think that if you put yourself in that point of view, then you can produce things that they will appreciate. But a lot of people in Patreon, they just sit there and say, look, I'm doing this, pay me money whenever you want. I'm not going to give you anything else. I'm not going to ask you for anything either. And that doesn't work well. Like, you have to be there for the people. So when they send messages and so on, you have to be there. And if they make a request and it's something that, that you can accommodate, you should do it. And I think that's a big part of the people staying in the community.
It's more of a relationship than selling a packaged good to someone.
Yes.
Yeah, it's almost like, in addition to being an open source developer, you also become a community manager at the same time.
Yeah, because in open source, the scarce resource is not the code, because the code is free. You are polishing it, so it's free. So it's the developer who is scarce. So the developer time is very scarce. And people understand that. When they talk to you, they always say, I know that you are very busy, but could you look at this or that? So to acknowledge that too, and give them a little bit of that time that you have, and make them feel that you are listening to them.
We've touched a little bit about how using FPGs to recreate old hardware is important for preservation, but I think that's something maybe people don't understand the nuance of. Is that a driving factor for you, the preservation part of this, or is it mostly because you like playing old games and you want people to play 1943?
For me, it's both. Like, as I said at the beginning, what drove me into this was the ability to replicate it exactly, which was not possible in a different technology. So that drove me into it. But I also wanted to play them. And there is this whole story that when I was working on 1943 and I was developing the core, and at that time was much slower doing that. I didn't have all this framework done. So it took me much longer. And my boy used to go there and play with a core that was only half done. And so he was used to seeing the reaction of the plane, the bullets, everything. And then we went to a place where they had one Pandora box in an arcade cabinet. And he played to that. And on the way home, he told me, there was something weird there. It didn't move right. So I thought, yeah, you can tell. Yeah, even a child can tell that it doesn't move the same way.
The old hardware is going to go away at some point, right? Like the capacitors and stuff on the old boards will eventually degrade to the point that you can't play the games on the original hardware, which is both worrisome, but it makes me feel good that there's this large group of people in the world working to save these. What's an important part of my lifetime? I grew up playing Frogger and Galaga and Miss Pac-Man and Donkey Kong, so it's exciting that's continuing.
It is, and the boards really die. Like, and they die on me all the time. Like, we get boards delivered that work for a few days, and then after a few days they stopped working. And now you either fix it and we don't have time to fix them normally because it's not easy to fix them. You may spend 1 week fixing a board. Even if you know the system perfectly, it's not so easy to catch a problem. So, they all die eventually.
In cases like the 1943 core that you mentioned, where you're replicating functionality but with a different circuit, does that require more testing after the fact to make sure everything lines up than if if you had the full schematics and you just did everything exactly by the book? For these like slightly more kind of workaround situations, do you have to test a lot more to make sure that it's all there?
In this case, it was much simpler, because if you connect the real thing, it's a full MCU that has its own memory, it has its own ROM, it has its own interruption, it has a lot of signals that you have to get right, and it's very easy to mess with them. Whereas the lookup table substitution was actually pretty straightforward. It just, from the point of view of the main CPU, this main CPU doesn't realize that there is something different connected to the bus. So that one was easy. So that's why I haven't changed it yet, because the replacement will probably not work the first time I try.
It seems like it leads to some interesting edge cases. Like I saw you retweeted another I assume it was a developer who was tweeting about, I'm not sure which version of Tetris it was, but they basically had two side by side. I think it was on the Analog Pocket, where I think it was the attract mode that essentially everything lined up exactly right up until a random number generator spit out a slightly different number, and then two different pieces came out. It seems like you might run into some really weird, like very minor niche kind of situations like that.
You get totally different bugs from emulation, because you face different problems. Like when I check the MAME source code, they talk about problems synchronizing two CPUs, for instance, because they have to do this. I run one CPU and then I run the other. And sometimes they have problems because the signals don't get across right in time, so they need to increase the interleaving, so they need to switch from one CPU to the other more frequently. So that's one problem that software emulation designers have. So I don't get that one, but I get different ones that can be quite challenging too. Like one of them is when the CPUs fight for a resource. If there are two CPUs and both of them are fighting to access a common resource, that can be pretty tricky in hardware, whereas in software emulation, because everything is virtual, it's very easy to do the handshaking.
Interesting.
How did you get started doing FPGA programming? I'm curious. I first heard about FPGAs 12 or 15 years ago, and it seemed like an interesting novelty and a kind of a DSP kind of competitor. But I'm curious how you found your way to that and how that led you to this path.
Because I heard about the MiST project, which is like the ancestor of the MiSTer. Like Sorgelik from MiSTer did a lot of work for the MiST, and I heard of that. And I had an Atari ST when I was young, so I thought that it was going to be like the perfect machine. So I got one, and I found that there were a few cores, but only a few. I was surprised. I at the time I thought it was going to be like the Raspberry Pi or something like that everything was going to be there, or there was going to be like a big scene of people, and it was pretty much no one. So I thought, if I want to have something, I have to do it myself here.
When you started first contributing to the MiST, and then obviously much more to the MiSTer, just in terms of your skill set and what you do at your day job, did those skills come over directly, or did you have to learn like a new language? Was there a ramp up like education that needed to happen? Did you have to like learn VHDL, or do you use that already at work? I'm curious how close those are.
Yeah, like in my day job up until recently, like I was they call a mixed signal analog designer. So I designed analog ICs, analog integrated circuits. Like, for instance, when you use one smartwatch, and you touch the screen with your finger, so the chip that senses that is the kind of project where I normally work. So I had a lot of experience doing all that, but not so much with digital circuits, because in big companies, they have some people for the analog, some people for the digital, some people for the firmware. So it's all very, everyone has its own space, and it's not easy to go across your space. But I had education, from college, and I was in the meetings with all the people who were doing that thing. So I knew the flows, I knew what it did, and I understood all of that. It's just that I couldn't do it in my job. So that was part of the attraction of doing in the FPGA, that I could do the other side of electronics that I am not supposed to do in my day job, because in my day job I am analog, so I'm not supposed to do digital. So that's something that I liked a lot about that. But I had, of course, I knew about electronics, I knew about software, I knew about design flows, methodologies, and a lot of things that are not so common. That's why, from the very beginning, I was doing things in a different way. And it has payoff in time because, like now when the Pocket came out, I was able to support it, very quickly. And it would have been able to do it faster if they didn't have like this horrible scheme of files. But the hardware side, it was very easy to give support to it. And once I gave support, like everything was working out of the box without touching anything because of how the framework was designed. And yeah, that's because of my day job.
Cool. When you were starting to make cores, like, was there a question that you would do open source in your mind, or did you feel like this was an open source project from the beginning?
I think that because I'm also a retro aficionado, like I think that for me there was no point in closing anything related to retro. Like we publish all the schematics. I think that all this information should be public, just because it's important from a historical point of view. So I don't think that, for instance, this Pocket device, should the Pocket be open source? Yeah, I don't think that's really relevant to the retro community. I think that if it's not the Pocket, it will be another device. But the information about, let's say, the Sega Outrun, I think that should be public because I think that has proved to be, historically important. And the Analog Pocket may not be historically important. It may just be one thing for the next couple of years, and then we will get a better device, and we will forget about the Pocket.
How has it been working on the Pocket, both in terms of working on the hardware itself and the development libraries and support there, and also Analog as a company? There's been some tension. Some might say they've been a little hostile toward the MiSTer community at times, and there's been some real kind of tense stuff going on there. Like, do you think that's died down? Do you think everybody's going to get to a point where they can be friendly and work together and everybody can benefit?
I think so. I think the users will see the benefit. I'm hoping that with Pocket users, the community size will double. That's my hope. And if the community size doubles, suppose that I go from 3,000 to 6,000 subscribers, then I could actually afford someone, with experience, someone who can, really contribute big things, who I cannot pay now. And so I'm looking forward to that. And people may think that, I'm always worried about how much money we make and so on. And yeah, and it is because I want to get this resource, because I know that I have this CP3 board with these 5 big chips there, and I'm thinking, wow, this is a lot of work. So we need to get it done before we all die. So that's why I'm a bit concerned about these things. But so I think the Pocket can be very good for the community, for the FPGA community and the open source community if we use it to fund open source projects. I think the Analog as a company, I don't think they are interested in doing open source stuff or in publishing whatever they have. Because I've asked him to look, why don't you do something for the community? If you have knowledge about how to make this work in an emulator where this is not supported, why don't you publish that? And they didn't. And I made similar requests about other topics, and they never did anything. And they don't want to finance any developer either, because they pretty much think of ourselves like software piracy or something. It's really, so I don't think the Pocket will help directly that company. But if the people using their product help the development, I think that's great. And I think, they should be very welcome to the FPGA community.
We kind of feel like it's always better to be inclusive than exclusive, right?
Yeah, absolutely.
Yeah, it almost sounds like at this point, the Pocket is just kind of a means to an end, and the end, of course, is growing the community, increasing support so you can do more work, even if Analog is not willing to play ball, the Pocket can still play a role. So the way things stand now with the work you've done on the Pocket and the work you're still doing on the MiSTer, how much extra work is there now supporting both platforms? Does your framework make that easier? Is it not that much extra work to now port cores to the Pocket? Is that not going to create a lot of extra overhead, or is there a lot more work there?
Well, at the moment, I can pretty much just compile for one or the other, just changing one argument in a command line. but I still have not implemented NVRAM, so non-volatile RAM support for the Pocket version. I think that's the only thing missing. And then this light DRM based on the Pocket chip ID, I have not implemented that either. So I still have worked for 1 or 2 days there, and after that it will just be. I mean, testing, we will test that they work, that they fire up. But maybe after a while, it won't be needed to test. Like, we don't test for all the platforms because now we are confident that if it works on the MiSTer and the Mist, it will work for all the other ones. So I think the Pocket will get to that point too. But it still needs, I think, at least 2 full-time days to get to that point.
I'm curious, now that you've got so much experience developing for FPGA, are there other categories of FPGA development you're interested in pursuing that are not related to classic games? Any other potential there for other cool projects that you might want to tackle?
Not so much. Like, FPGAs are used a lot in, let's say, in serious business. Like, the mobile phone antennas that are used as repeaters on top of buildings, they all have a lot of FPGAs inside because that's a classic use for them. But that kind of work it would be very similar to what I do in my day job. So I've always wanted to do mathematics on the FPGA because you can do so many things in parallel that, like, physics simulation on an FPGA could be very interesting too. But it's like a whole other business. Nothing to do with this.
There's a moment when I first got my MiSTer before my RAM board even came, and I think I loaded up the Genesis core, and I was looking at the switches that were available in that core, and it was like, oh, which sound chip do you want to emulate on or do you want to run on your Genesis games? And I loaded up Sonic, and for the first time in 30 years, I heard the music that I remembered from my 2nd gen or 3rd gen Genesis. And it's like, I have to imagine you kind of have those moments on the regular when you're recreating these older boards. Do you have a favorite? Do you have something that really sticks in your mind?
Like, the most recent one could be like the yellow flashes in the Ghosts and Goblins game. Like, I remember that because we haven't seen that in emulation for even now for these 20 years, and it was something that it was visible in the real hardware, that sometimes the screen just went yellow. And the first time they told me about that, I thought maybe it was in the hardware, but maybe it was a problem with the boards. Maybe it was not that the design was that way. And some people insisted, and it's good that people insist. And as I said, I did, all the messages, and I looked back at that, and I realized that I had actually fixed a bug when I was doing it, fixed a bug in the actual board, because I thought that was not well connected. So I fixed that. And once I removed that fix, I got the yellow flashes, and that was wonderful.
Have you been looking at the folks? I know that there are some folks that are working on using FPGA emulation to emulate like phosphor glow and things like that on modern displays. So for folks who don't know, it's like Sonic's another good example of this. They would flash waterfall effects so that it looks semi-translucent and rely on the phosphor glow of the CRT degrading over the time between frames to make it look like there's some transparency. And I'm curious if you're following that side of this of the preservation.
Yeah, I think I really like that part of it. That because I'm not so much fan of the of the square pixels because my screens were not perfect at the time. They were like the cheap TVs that nobody wanted to have, in the living room. So they ended up there. And then I know that the FPGA can do all this real-time video processing very well. So I used to add a little bit of processing as options in my course, especially. It's still in the Mist version, for instance. It's not in MiSTer because now the MiSTer has very good filters. But that development, I like that a lot. Like, I have, I have been browsing the different filters, selected the ones that looked best for me. It's also a good example of how there is no perfect solution that will fit everyone. That people have to go and look for whatever looks fine for them. It's similar to what happens to the SID chip in the Commodore 64. That for a while, a lot of people asked me to work on that. And I was looking at the schematics and so on. And the schematics have a lot of analog chips. And I understand analog circuits inside the schematics. And of course, that's my specialty. So I understand what those are doing. And I also understood how much variation they were going to have because of the way they were designed. And I thought, this is not going to sound the same for everyone. So no matter what you do, people are not going to be happy because these chips have so much variation by design that the only way to make people happy is to have like a lot of knobs there that they can play with. So that's one reason why I never got down to doing it, because I thought, you will never make everyone happy with this chip because it's too much variation.
So now that the MiSTer project is fairly mature, it's been around for a handful of years, I see more and more discussion in the community about like, oh, what is the successor board to the DE10 Nano going to be? You know, I see people looking at like, oh, here's this $1,000 Xilinx development board. Somebody's going to buy one of these and try to evaluate it. People seem like they're hungry for, you know, the next big thing. Ever since it was kind of determined that Nintendo 64 is probably too much for the DE10 Nano, people are like, oh, what can we get to do better consoles now? Do you see that happening, or do you think that the project is fairly settled and that there's not going to be like a succession of new boards down the years?
No, I think we need a new board, but we are not in a rush, and it will only serve like a few games or few systems, because like pretty much everything up to the year 95 or so will fit in the MiSTer already. So that covers really a lot. Like if we have been able to get even the PS1 there, well, the PS1 is a little bit deceiving because it is 3D, so we think that it's going to be very complex, but it is still like a kind of a slow CPU, 20-something megahertz. So it wasn't, as bad as it looked, from a recreation point of view. Still, I think the effort on that project has already been going for over a year, and the engineer doing that, he's a professional engineer who's been working professionally on FPGA, so he knows his business. So if it's taking him, all this time to do it, it's because it takes all this time to do it. But yeah, if we go for the Nintendo 64, I've talked a little bit to the person who is working on that, but I just look at the specs and I think this is not going to work, or you have to make big compromises here or big tricks to make this work just because of the speeds. I think people could be interested in a PS2 recreation. Like, I've been told a little bit about that by YouTubers, because when I've been interviewed by YouTubers, then they tell me, look, all my audience wants always to hear news about PS2. So either PS2 emulation, PS2, new ways of loading games, things like that. So why not PS2 on FPGA? The PS2 is not an easy development at all. It's crazy. Like it's very modern, and it took a large team of engineers to do it. And that's something that really it wouldn't fit on a MiSTer FPGA. But yeah, if you design a board that has maybe 2 or 3 large FPGAs, I don't know, maybe you can get a PS2, but not done in a month by one guy in the night. That's going to take a big effort to do.
Yeah, it seems almost like it's more a matter at some point, depending on the complexity of the console in question, it's less a matter of can the board handle what needs to be recreated, and more do humans have the capacity to implement this much functionality, right?
Yes, because we have the advantage of tools, of software that the engineers in the 80s didn't have. So that's why we can be more productive. And now we can test in hardware in FPGA just compiling 15 minutes, which may sound like a lot, but they used to have to make like boards to test them. So that would take them days. So we have this edge over people in the 80s, but we don't have that edge over people in 20 years ago. They already had the software, they already had the tools. And so now it's the headcount and experience. So that it levels the play field. So and then it's also the clock frequency, that an FPGA inside has a lot of switches connecting things. These switches slow down the electrical signals. So even if you have a high-speed technology, because the transistors are very small, you have these switches slowing them down. So they slow them down to a point that they are still very far compared to technology in the 80s, but they are not far compared to technology in the year 2000. No, and if you compare them to the technology 10 years ago, they are slow. Now they're slow. So I don't know if we'll be able to make a PS2 ever, but it would be a very cool project.
Thanks again to Jotego for spending so much time with us and chatting about, his process and everything about this project is amazing to me. I'm thrilled that it exists. I love having one on my desk. When I want to have a quiet moment playing an old game, it's my favorite way to fire it up. And the open source preservationist ethos here makes me very happy. So
it is, I mean, hyperbole aside, it is nothing short but of the most exciting thing in video game preservation that I have ever seen. Just the range of things it does and how well it does them. Is just mind blowing. And
the range of it literally encapsulates the first 25 or 30 years of video game history, right?
I guess that goes right back to my games emulated to space taken up ratio. It's quite literally what you said up until currently about 90. Basically, the PlayStation and the Saturn are on their way, or are working in some fashion already. So basically everything up to about the late 90s, besides the Nintendo 64, all in that tiny little device.
It's a little mechanical, it's a little electrical marvel, and I've thoroughly enjoyed having one. So
yes, and just so grateful to Jose for taking the time to talk to us and letting me pick his brain about when Mortal Kombat is coming.
I was going to say, are you happy with your answer, Brad?
Extremely. So there was the thing we touched on in the intro. There were multiple generations of Midway hardware, and he had just said Mortal Kombat, those words, and that could have just meant that very first board that just ran MK and Smash TV, but it sounds like they're dedicated to getting all the Midway hardware working, which is a whole bunch more games than that.
Love it. As always, this week's episode of the FOSSPod is brought to you by Google Open Source. They bring all of the value of open source to Google and all of the resources of Google to open source. Matt Purdy produced this episode. Sabrina Hill edited it, and we talked to Jose, which was a real treat, I think. So
yes, a privilege for sure.
We will be back in a couple of weeks with another episode of the FOSSPod. Thanks everybody for listening, and we will see you then. Bye-bye.